The title of the project is Recurrently Decomposable 2D Convolvers for FPGA-Based Digital Image Processing. Here, a 2D convolver's recurrently decomposable image is going to fed into a FPGA kit which is based on the digital image processing. The term 2D convolvers means it has only rows and columns in a two dimension, and FPGA means field programmable gate arrays. The combination of so many devices into a one kit itself, it is FPGA. So we can use only a specified device in the FPGA for our requirement think. The field programmable gate array will be a good choice of a device for performing with a 2D conventional. Yet your specified image is going to perform as a 2D conventional, that is two rows 2 column conventional. So this field programmable gate array will become a good choice for performing this 2D conventional, because the ability is fully exploited in the parallelism involved in the spatial operation. The existing system of this project is the recurrently decomposable filter design method will reduce the computational complexity of this 2D conventional, because splitting the convolution between an image and a larger mask will be get into a sequence of convolution using several smaller masks. The 3G FPGA architecture is proposed based on the RD filter, which has a different buffering scheme. The term buffering scheme means loading scheme. The conclusion is that this RD will be based on a architecture to achieve a high area efficient than the previously reported one. Especially it should be based on some architecture because of the larger convolution mask. The disadvantages of the existing system is to implement the FPGA were realized on a low cost, and the complexity will be get reduced. The proposed system of this project is we going to use DCT algorithm to modify the image compression using the FPGA implementation. By using this DCT, the image will be compressed as a 4x4 method. The complete image will get into a 4x4x system, and it will compressed into a FPGA implementation. This architecture is used as a core of FPEG compressor and the critical path in FPEG compression hardware. The 2D DCT calculation is made up of 2D DCT separability property, where the old architecture will be divided into two 1D DCT calculation by using a transpose buffer. Here the 2D DCT will be get divided as 1D DCT and 1D DCT. Using this 1D DCT calculation, it is possible to generate the same result of this 2D DCT. The advantages of the system is the DCT properties will achieve the compression and the encryption. The compressed image will be the same as the encrypted image. So this DCT properties will achieve both the compression and the encryption. The area and efficiency will be better in this DCT properties. application of this system is the trade-off between the system will be a accuracy and efficiency one. The upper bound or error tolerance will be a good one, and the FPGA implementation will be a low cost one. The system requirement for the system is MATLAB 2014A software has being used, and the tools used in this application is image processing and computer vision. In image processing, where the image is getting processed, and in computer vision, where the image is detected and tracked. The techniques used in this project is recurrently decomposable 2D filters. The recurrently decomposable 2D filter means it is a separable or a non-separable one, according to whether that they can be decomposed in a tensor product, that is a two 1D filters, where the 2D filters will get split into as 1D and 1D. By this 1D and 1D separation, the convolution of this two smaller 2D filter will be look as the same as the 1D and 1D filter, and the quality of the compression will be good. And the second one is RD based architecture system. The architecture design is based on the RD. Here the FPGA architecture is as the based on the 2D convolvers. Each part will be supported by different buffering. Here the external memory device will set into your 3 FIFO, that is first in first out, and this again will send into the pre cross Q, that is 2D P cross Q window, and finally it will send to the 2D conversional kernel. The 2D means row and column, 2 row 2 column, and again it will send to a temporary memory. It will be the convolver 2, the first one will be the convolver 1. In temporary memory, this compressed image will go into the encrypting process. In the encrypting process, this temporary image will be given into the again as a FIOO, first in first out, then again as a J cross K window. Here we used P cross Q window, here they using J cross K window, and again it will send to the 2D convolution kernel. Here the recurrently decomposition is based on the SWPB architecture. The future work of this project is, while compressing the image, the quality of the image may get damaged. So the area to enhance the area efficiency, we use a architecture selection. So we have to suggest some more selection to enhance the area efficiency. So we can use Dowbetch's wavelet to improve the quality of the compression.